Okay, going through the Kaplan GED prep class. The Kaplan that I'm using is 2021, but an awful lot of the tests are the same, so it may match up with the book you have. Question 12 on the practice test, first practice test, whatever, on page 596, is about exponents. And the question they have is a number and then the little number. And they ask, what is the value of that? There is no way this would be a question. I doubt very highly, it's not very highly, that this would be a question on the GED. They would not ask it directly like this. So let's go over exponents. Also, there's bonus stuff in this that is not in the Kaplan book that I know will be on the GED test. One or two questions. There's extra free stuff here in that gigantic yellow pages looking book. Okay. Who uses the yellow pages and what am I talking about? Anyway, remember, this number is just a repeater. It says how many times to write 5 when we multiply 5. So it's 5 times 5 times 5 times 6 times. Or if we type that into a calculator, 5 times 5 times 5 times 5, we just have to keep in our head, count to 6, and that's the answer. It's just not how they're going to ask. So when we see, what we want to do right now is whenever we see anything with a tiny little number on it, x to the second power, that means x times x, not x times 2. We want to imagine that there's two exactly the same x's sitting on top of each other stacked, and we can't tell how many there are, and we got to multiply because everything that touches in algebra, anything touching each other is multiplying. 3 times x is 3x, you know. So that lets us know that there's a stack of 2 x's there. This lets us know that there's a stack of 3 7s there. So it's 7 times 7 times 7. So that's our exponents. Also on our order of operations, we do everything parentheses. The second thing is exponents. It is the second most important thing. And even if there's work to do inside the parentheses, we still follow dear Aunt Sally and for her rules, parentheses, and then exponents are there. So let's just decide to be entirely comfortable with tiny little numbers and letters and numbers next to them. But here's the part that's not in the book.
There should be 14.
Okay, so there is a thing called the rules of exponents. And I tried looking for it in the Kaplan book. It may be there, but I couldn't find it. There are 6 rules to exponents that are on the test. So if you saw this as a question, if we come across this as a question, you know, math problems, sometimes it's tons and tons of words in a word problem, and they bury the numbers in there. Or other times it's just math and then one word like solve. So it's like barely any help. A question like this is going to come up on GED Flash and all those things on the GED these questions keep popping up. So it's a good thing to be prepared for. On the grid or whatever of questions, I'm going to do this real quick, where there's easy question or doable questions, difficult questions, long questions, or short questions. So S for short. No, we should call it fast. So fast questions we can do quickly, long questions that take time, doable and difficult. There are doable questions that are fast. There are some that are just straightforward and you can do them in 30 seconds. And that's an area we want to be great at. There are doable questions. There are a lot of work, like putting numbers in order from lowest to highest. That takes some work. Or, you know, there's some things in geometry that, okay, it's doable, but we got to put and they take up time. And remember, it averages out to 2 minutes and 30 seconds per question. So we want some of this time to help this area out. There are difficult questions. There probably should be a second F there. Difficult questions that are fast. That's this. These rule of exponents questions are fast. But the thing is, do we know how to do them? So there's 6 things to memorize. We're going to go through all 6. So that's this area. And then there's difficult questions that take a long time. This area, we want to survive. We want to be awesome at these three. The difficult questions that take a long time, guess. Try to eliminate two answers, put the answers on trial. Those are the ones where we want to flip the game. We don't want, this is a swamp. These questions are a swamp. So instead, look at the answers, go, what can I knock away? Take a deep breath, you know, think about 46 questions is like a 46 round boxing match. You know, no champion who ever won every single match afterwards had, you know, didn't have a bit of a black eye. So we got to look at it and go, well, they're, you know, he might win this round, but we're going to win the fight. So with all that being said, see how well I can erase all this. Boop. There we go. Goodbye, Bob. Why this stuff is good to know. Y to the 4th power times y to the 11th power. And here's our 4 choices. So this is called the base. Whenever you have a big number and a little number, this is called the base. The base doesn't change. And if the base matches y to the 4th times y to the 11th, then y is still going to be big. So these two are no good. I'm going to cross out just the C and the D because they took the base and made it the exponent. So that's them just trying to throw a whole bunch of stuff at us and see what, you know, what sticks. Nope. Oh, well. So we're still trying to solve that. So that leaves us with these two. And if we just look at them, crap, I didn't write this right.
Yeah.
That's gotta be 15. My bad.
I saw that, but I didn't, you know, like, A is definitely not going to be right.
Yeah, I tell you, the coffee hasn't taken yet. Happens when we stay up and watch Godfather 1, Godfather 2. Like, all right. So 4 plus 11 is 15. 4 times 11 is 44. And I wrote the X for the multiplying thing. They could write it like this with parentheses around both. You know, they could do it that way if they wanted. You know, they tend to get a little fancy with this stuff. But all we know what we're doing is multiplying. Well, since there's the only sign there, that's the only sign, this would be very tempting to do.
Mm-hmm.
And we have to know the GED question. They know what they're doing when they write these answers. There's the right answer and the distracting answer. And we already eliminated 2 choices. So I'm going to go down here and going to go, let's simplify the idea. If it was 3 to the 2nd power times 3 to the 3rd power, this is just a repeater, right? It'd be 3 times 3. Mm-hmm. And I'm going to bring this times down. And then this is 3 times 3 times 3.
Right. 3 times 3 times 3.
Now, we're not going to figure out what 3 times 3 times 3 times 3 is. But if we look at 3 times 3 times 3 times 3 times 3, that's 3 to the 5th. Because the repeater says, well, how many times you repeat it? 1, 2, 3, 4, 5. So that's where we add.
And that's what you call 5.
If I changed this to X, let's see how neatly I can do that.
Okay.
If this was X to the 2nd times X to the 3rd, let me get away from the hint right there. This would be X times X. That's what that is.
Uh-huh.
Then this time is that thing. And then X times X times X is that. So blah, 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 blah right there. That would be X to the 5th. So the answer, now that I've written it right,
mm-hmm.
When we recognize this stuff, it is a second long problem. There's no math except for 4 plus 11. And that's one thing they'll do on the test that GED will do. They'll do a small number and a big number. That way it's extra hard to sit and write that stuff out. You know, so a simplified version, doesn't matter these numbers are small, we can see that that's how it worked out. If we had done, you know, y times, 4 times here and then 11 times here, it would end up being 15 anyway. So that is rule number 1. If the bases are the bases are the same, Now I'm going to put a times dot in there because I'm using x's. If the bases are the same, we add the exponents. So that's rule number one. And this is, there's not a lot, I mean, of all things you have to memorize, this is sort of a standalone, probably 2 questions out of 46 would be here, definitely 1. And of the 5 questions where we can't use a calculator, our first 5 questions, this is a great place for one of those questions. So right out the bat, they're throwing something at us that looks, you know, awfully confusing. So here's the visual for the rule. I'm going back to the X for multiply. If the big numbers are multiplying, that's the X for multiply. We're going to push this X multiplying symbol over just a little bit and roll it over and turn it into a plus sign. If the big numbers are multiplying, the little numbers are adding. So that's rule 1. And again, I've found it in the Kaplan book. But it's probably there. I haven't read all of it because the thing's a monster. So that's rule number 1. Rule number 2, we just did multiply. So now we're going to do divide. So if it was x to the 11th divided by x to the 4th, or they could write it like this. You know, fractions are not division problems. They could write it like this. That's x to the 11th divided by x to the 4th. And clean up my letters because that looks crappy.
We knew what it was, Jeff.
Yeah, you know, it gets pretty bad here sometimes. So if multiply, we rolled over to get add. Well, the cousin of multiply is divide.
Divide, right.
And then the brother of adding is subtract. So roll this thing over to add, and we just take away the dots of divide to be a subtract. So we subtract. And so this would be x minus 7 also, because fractions go top down. It would be 11 minus 4. And the way this makes sense is if it was 3 times 3 times 3 up top and 3 times 3 on the bottom. So in other words, 3 to the 3rd up top, 3 to the 2nd on the bottom. If we expanded all of that out, these 2 would cancel out and all you'd be left with was 3. So 3 minus 2 is exponent 1. Exponent 1 tends to disappear because they're ghosts. So it would just be 3. So rule number 1, if the big numbers are adding, roll that thing, I'm sorry, multiplying, then the little numbers are adding. We roll that thing. If the big numbers are dividing, we get rid of the dots and we subtract the little numbers. So we're 2 out of 6. Next is something like this. Let's use a number. 3 to the 2nd to the 11th. Again, that's the way GED would do it. They would do a little number and a big number. So I'm going to do a little number and a little number. And it'll get sloppy, but it'll make sense in a second. So this is power of a power. Dear Aunt Sally, please use my Dear Aunt Sally, says, do what's in the parentheses first. So that is 3 to the 2nd, which is 3 times 3. Then this number comes along and says, cool, whatever you did in that, do 3 more times. So I would have to go 3 times 3 times 3 times 3. And that's 1, 2, 3, 4, 5, 6. That ends up being 3 to the 6th. So if I get rid of that, you can see that all we did is 2 times 3 equals 6. So when it's power of a power, we multiply the powers. So this would be 2 times 11, 22. And this is going to be a monster number. It's going to be huge because it's times itself, times itself, times itself, times itself. It's going to be big. So that's our rule. If it's power of a power, we multiply the powers, which sounds like, some old Saturday.
What was the answer? What was the answer for that though?
Well,
3 to 22?
3 to the 22. Yeah, we multiply those two numbers.
Okay.
So rule number 1, I'm going to do big. This is rule number 1. This is rule number 2. If the big numbers are multiplying, the little numbers, we just tip that thing over just a little bit. We're going to add. If the big numbers are dividing, we get rid of the dots and we subtract. If it's power of a power, then we multiply. Power of a power, we multiply. That would be, but that's x for multiply. So this would be z to the 33rd. So on that grid, this is a tricky problem, but if we know it, we know it. And it doesn't take much time. And we can put 2 minutes or so. I mean, imagine seeing a question like that on there and going, man, I could take a breath. I could give myself some positive self-talk. I could look at the time. I could check out, all right, I'm question 9. I got a long way to go, but I'm, steel yourself up. Give yourself some positive feedback. Tell yourself you're a champion. Do that superhero pose, whatever. And, we're going the distance on this fight. The next 3 ones are a little weird, and they're just plain old rules. So we're going to do them quick. Rule number 4, anything. Oh man, I'm going cursive. I didn't even mean to. Anything. Oh, there's my penmanship grade. A solid C-. Anything to the 0 power equals 1.
1.
And everything in my brain says 7 to the 0 power should be 0. But it's not. It's 1. It is a 1. So I'm going to write that there. That's my mental trigger. If I see O up there, I'm saying I'm 0, saying it's O and 1, which should have it. My doctor. I will call doctor back later.
7 to the 0 would be 1.
Yeah, anything at all. There's almost nothing to memorize here. So 8 to the 0
is 1.
1. And what I've seen GE do, instead of making this its own exponent question, they will weave that into some longer problem where there's multiple steps. So it'd be a whole bunch of math, 74 divided by 2 times 8 to the 0 power.
And that's just 1.
Or they would work, they would work this thing out. And it would be so easy to go, okay, dear Aunt Sally says I got to get rid of this exponent, to go, well, 7 to the 8 to the 0 has got to be 0. And anything times 0 is 0. And okay, the answer is 0. But it's not. It's 1. And then anything times 1 is whatever it is. So I'm figuring that thing out. So that's rule number 4. So here we go. Rule number 1, big numbers multiply, roll it over, little numbers add. Rule number 2, big numbers divide, little numbers subtract. Rule number 3, power of a power, we multiply. Rule number 4, anything to the 0 power is a 1. And now we're going to do 5th and 6th real quick. Negative exponents.
Took 2 seconds.
Okay, so I'm going to draw an example over here. I'm going to use X instead of 7. Now this is one where, again, we sort of, sometimes we got to step out of math and sometimes totally make sense. Like those first rule 1 and rule 2, if you do the math, you're going to draw it out, it kind of makes sense. This one, it's purely a physical thing. We got to go, I'm doing this one right now. We're taking that negative and we're going to draw it out and make it a fraction and throw 1 on top. So it becomes this. And that's it.
That's the answer, Jeff?
That is the answer for that. That as far as we can go. If they gave this as a number, if they said this to us, draw the line out, put a 1, and then we can, the 2 stays with the number down here. The exponent stays with that number. So we do 7 times 7, and 1 over 49. But I haven't seen GED do a ton with the numbers. Usually it's just with the letters. So Z to the negative. Sure.
But it's actually X to the negative second, but you just add a 1.
Yeah. I'll put this back the way it was. Yeah. So that's what it started out as, and it becomes this. So we turn that negative into a line for the fraction, throw a 1 on top. And now we can just think, how many times in our lives are we going to use this? It's got to be hundreds.
Oh my God.
But it is one of those tricky questions. It's one of the, it's one that takes a little work, but it doesn't take much time. So I'm going to clear it out. If the big numbers multiply, the big numbers multiply, the little numbers add. If the big numbers divide, because that goes down, fractions always go down, then the little numbers subtract. If it's a power of a power, that is powerful. The little numbers multiply. Anything to the 0 is 1, because 0 is really an O. And then I didn't give myself much room. What did we just do? Oh,
we just did add, and well, I wrote it down as add any. Was that right? Any letter with numbers, add 1 over it with a negative number.
We drag the negative sign and make it into a fraction. And if there is math, the exponent still goes to that bottom number. So that would end up being 1 over 49. If they just, because there's math left to do. If it was just like a normal letter, we'll drag this and do that. So I should probably do this that way. That's five rules. The last one is down the road, pure weird, but we just gotta do it. This is rule 6, and rule sucks if it's a fraction. Here it is, straightforward, pure memorizing. This may be a question. If it is, I want you to think about how great it would be to just go, look at, they are throwing heat. This is a 101 mile an hour fastball. This is did you get to question page 972 of the textbook? This is all we do. We draw that. Remember we said, I think on a previous video, we said this No, let's use 4 to the second power means 4 times 4, and that means 16. Well, that's one direction. We can go backwards, and that's this little house that's on our calculator, and that's asking the square root of 16. Well, what number times itself?
Itself gives you 16. Yeah. Okay.
So that's what this symbol is. X inside the house, and you kick the down number out. The down number goes outside, and the top number stays. Why does that make sense? Who cares? Get the question right. It's the cube root of X. Yep, it's just another correct answer that takes no time. So I'm gonna erase this junk down here. That's what that square root radical house is. So if we did y to the 4 thirds, I don't have a real good way of, when it's a negative number, we draw the thing out and make a fraction. When it's a fraction, we make a radical. Put the base in here because the base never changes because it's all about the, and we kick the down number out, and the big number, top number stays. Top dog stays, down number out. That sounds like Isaac. That's what Isaac would say. Top dog stays, down number gets kicked out.
Okay, so
6 things to memorize. These are note cards, flashcards kind of thing.
okay, so with this
And
last
it's
one
like-
that you just done, so what are we trying to figure out? 3, or is that just the answer? That's just how you write it.
This would be
Yeah.
how we change turns into that. And then I've never seen on GED. We'll take that further. That's not it would just be where did the 2 numbers go. So this is cheat code kind of stuff. They are difficult down the road. This is far down the road math. Probably calculus. I don't even know what area math this would be, but the answers are right there for us. So what I'm going to do, rule 1, just to recap, big numbers multiply, tip that thing over, little numbers. Rule 2, big numbers divide, knock out those dots, little numbers subtract. 3 is power of a power. That one we multiply. 4 is anything to the 0 power is 1, which is weird because the y just disappears. So that's a weird one.
So if you would put Y1, it would be wrong.
Right. Yeah. And it's just like it's just like we have to train our minds that this just looks weird, and it
I
does.
train my mind that much to know that it looks weird.
And x to the negative exponent is, we just take that line and drag it out and do that. And if there's some math to do down here, we do it. And the 6th and final one is, let's do y to the 2 thirds. We draw the radical sign or the house or whatever. The base goes in there because the base stays. Down number gets kicked out, top dog stays. All of these can be solved in 10 seconds. And deep breath, pat yourself on the back kind of thing. We're all, question 16 on the test is 30 questions away from being done. And when we get
How
tired,
can you get right?
we're shooting for 26.
Okay.
And who was Eisenhower, Patton, one of those generals said, fatigue makes cowards of us all. When we get tired, we start thinking of the things we can't do instead of what we can do. Fatigue makes cowards of us all. So when we do the stuff, we have to know fatigue is coming. You know, nobody practices for a marathon by crossing the finish line over and over again. You know, you got to practice running mile 7 so that mile 14 isn't so bad. And I know why I'm talking about this because I've never ran a mile in my life. So someday a bear's going to chase me. I can run that. Actually, I think I told you, I know how I want to die. I want to be 90 years old, and I want to.
Don't you want to stop recording?
I want to fight a bear. So me and the bear are just grappling out. Probably gonna have 4 good seconds of fighting in me, and then we both get struck by lightning as we're staring at each other, and we trade souls, and our souls get merged and they have to bury us together because we're all burnt. Giant coffin. That's how I want to go out. It would just be like people would come from miles around to see the man bear coffin. And that's on this video. I forgot to pause it. Awesome.
Didn't you hear me say, don't you want to stop recording?